context graph or context actually enhances the knowledge graph to include the decisions that you made in past, and then how are you going to use it.
Welcome to It's About Data, episode 43. This time we're chatting with Sudhir Hasbe, President and Chief Product Officer of Neo4j. Among other things, we're discussing context graphs for AI systems.
Hey, Sudhir. Good to see you again. I think the last time we crossed paths was back in the fall in Times Square. And I took a picture. I did a LinkedIn post that basically had Neo4j, your company, that was up on the marquee at NASDAQ. And my LinkedIn post just went viral, positively viral. People are talking about graphs. We always keep wondering, is this going to finally be the year of the graph? But I think what I really want to get a little more specific on, because of course it's kind of hard to have any conversation today without talking about AI, is that we've been hearing a lot of late about context graphs. So here, can you tell us what this is and why are we talking about this, and should we be talking about this?
Very good question.
We should absolutely talk about context graphs. You should talk about graphs in general all the time, but context graphs are really something to talk about. I think, see, historically, we have thought about our systems, especially AI systems or even agentic systems, powered by data. It's all been about data. But actually, as the evolution of AI systems happens, it's not just about data, it's about the decisions and the decision traces that you have done in past. You can, of course, data is going to be critical, but just data is not enough. You need to track your decisions from past. What were the right decisions? What were the wrong decisions? Why were the decisions made? What was the context within the decisions? So next time you're making a decision, you can go back and look at like what were the right or wrong decisions, what was the context of it, and improve your decision making going forward. I think it all comes down to not like what AI systems can do for you. I heard this recently. What can you trust the AI systems to do for you? And
Yeah.
these decision audits and traces in context graphs can help you improve that and give you a trace of what decisions were made and why. So hence context graphs are really important, but
Yeah.
I think it's just an evolution.
Yeah, just one follow up is that we were hearing a lot. About if we had this conversation a year ago, we've probably been talking a lot about knowledge graphs. Is this basically kind of just a variant of knowledge graph or something different?
It's just an extension or evolution
Interesting.
of knowledge graphs, is what I would say. See, historically, if you think about what is knowledge graph, like knowledge graph is your domain data, right? This is the domain model. Like a lot of people will talk about domain models and all. This is knowledge graphs include all your domain information, domain data. It has the semantic layer or semantic definitions. What does something mean within a business? Not just there's a product, there is this, but what does like revenue mean? What does a fiscal year mean? Those kind of definitions go into knowledge graph because that's what you map. You define your business rules and policies in knowledge graph so you can apply these workflows and what workflows you want to run and all and what the rules are. And then context graph or context actually enhances the knowledge graph to include the decisions that you made in past, and then how are you going to use it. Now, can you have just a knowledge graph of context? Sure, you would call it context graph. You want to go ahead and have just a domain graph within the knowledge graph, and then is that. I think about knowledge graph as this overarching enterprise level graph that you put all your different information to power your decisions. And like into this, all AI systems need knowledge, and knowledge graphs are the best representation of all your knowledge, whether it is conversational history, whether it's decision traces, whether it's your domain or reference data. And in some cases, you may just keep the semantic and the metadata rather than keeping all the data in the graph. Like we have customers that are keeping their data in Databricks and Snowflake, use Neo4j. Actually, EA is one of the best examples of this, where you're keeping the semantic definition of your enterprise in the knowledge graph, but the actual data is sitting in other platforms in general. So that's also how you can represent everything.
So let me ask you a related question. And this question actually goes back to before the AI era even. I was talking actually recently about Catalog and Cocktails, another podcast that we're going to appear on soon. The episode will be released about the cultural issues around graph databases. And the cultural issues, as I see them, is that people learn about data, they get into it through Excel, through SQL, but there's a struggle to bridge a cultural gap to get people to understand how graph databases work so that they can start integrating them into their data workflows, be it data science or data warehousing, like you're talking about, like meshing these two halves. How do we overcome those cultural issues so that these tools like context graphs and knowledge graphs can be more integrated into data teams?
I think you're absolutely right, right? Like I have a lot of these conversations with our customers, and whenever I tell people, okay, can we just whiteboard and explain to me what your data model looks like or what data you want to store? People will go on whiteboard and draw a graph, like real graph representation. But when you go back and put them into like, hey, why don't you build something? They will put it into rows and columns and put it into an
Mm.
Excel sheet, start there, and that's how they will do. I think I completely get that. First of all, what is changing in the world? Let's talk about that. Right? AI systems require a lot of varied type of data, and it's an ever growing data. Like we started with all the stuff as we was talking about domain data, the semantic stuff, and ontologies, and all these definitions in graphs. And now suddenly we think that decision traces are important as the data that powers all these systems becomes bigger and bigger and varied. You have different types of data, different things, whether it's vectors, whether it is newer and newer data objects that come in. You can't have a relational or non other data formats to keep expanding. How many tables and how many rows, columns are you going to keep creating to keep different types of data? So graphs are more natural representation of it. Now yes, there is learning curve sometimes for people to get to know more about graphs and build them. But I think where we have invested a lot over last couple of years is how do we simplify that? So literally
Mm-hmm.
now you can go from your data structures that may be in your systems of records like your Snowflake or Databricks or relational databases, and we can generate a graph within 3 clicks out of it. And the way we do it is we actually use large language models. We have our own trained models
Okay.
that
Mm.
actually take your metadata and the context and the sample data set. We send it to the LLM, ask it like, can you map it to a graph data model out of it? And you get like a starting data model just out of the box. And in 90+% cases, this is good enough. This used to take our field engineers like days. It is like 5-10 days to work with customers to map the graph data model. We can do this in like minutes now. And then from there, you just get the model ready. And then you can do ingestion automatically, and we do imports and all. We have done the same thing for unstructured data, where you can give me a document. We have something called External Knowledge Graph Builder. This is a showcase to people. Anybody can go find it. You can go online, get a PDF document, and just import it. We will create the whole graph out of it. You can define what kind of entities you're looking at and all that. So just this simplification of creating knowledge graphs from structured unstructured data, we have like automated a lot of that stuff. And I think that is the precursor requirement for us to get mass adoption of graph technology anyway. So I think that portion we have taken care of in last couple of years. And I feel now it's more about what is more valuable to these AI systems. What kind of data do you want? Do you need reference data? You want like defined semantics? You want to go ahead and put context information so that you can make better decisions, decision traces as part of context graphs. All that is just like different types of data. And a lot of the context graph information will be not in structured store, right? See, structured databases, relational and all, or columnar were great at restoring facts, right? They will store, hey, this is the product, this is the sale, this is the customer, that. But the decision about why somebody bought something or why somebody returned something, it may be more in the unstructured format. It may be long form format. It could be email. If you did an exception process for approval of something, that may be in somewhere written in Slack. And I think taking this unstructured information, converting it into context graph is actually a important thing, and we have a bunch of tooling that we have worked on to simplify
Yeah.
that.
So I'm going to challenge you here a little bit. And
Yes.
part of it is going to start with like a little bit of a wordplay. You were name dropping EA before, and I was thinking
Yeah.
about kind of the double meaning of this, because I think you probably were talking about electronic arts,
Electronic
which
arts.
I presume is
Electronic
one of
arts.
your, but I was
Yeah.
also thinking enterprise architect. And this ties into the point that I kind of want to throw at you. I'm very much blown away by how you're describing how you can start to use AI to help basically build the context to guide AI. Because the thing is, we've had a huge issue for the longest time, dating back to the days of knowledge management, which is how do we put these corpuses together? Can we do? And it goes back to the days, of course, of like basically semantic, the semantic graphs, basically using the the RDF framework and it was one of those ideas that's just nice in concept, but was very difficult in practice to basically get your arms around manually. This is where I want to issue the challenge to you, which is that I believe that you folks, and I don't mean just you personally, but you folks in general, have not gotten this message out. Because when I was doing my research looking at the year back and the year ahead, I was expecting that last year was going to be the year of knowledge graphs, and I found very little reference. I mean, I saw lots of research and lots of papers talking about how this is great. I saw very little actual evidence of adoption. I'm sure there's more evidence of adoption. I'm sure there's more adoption than there is evidence at this point.
Yeah.
But that's still where there's a lack of smoke. There's just not enough fire. And I think, and I want to ask you how you folks will respond to this. Is that how do you get this message out that you can start to use AI to help put this stuff together? And also, where does the human in the loop come here? Because you can't just all of a sudden say like, oh, AI has figured out our knowledge model for for our whole company, obviously. So kind of put this in perspective. How do you get this message out? And two, how do we get this into the right perspective?
I think that's a great point, Tony. I think sometimes getting the word out and making sure more people know what the whole world is doing is actually more important than actually doing some of these things. You're absolutely right. And first of all, let me cover the human in the loop thing. Whenever we create data model out of like the graph model from your existing data, we do give an option to the user to review the model, optimize, change it so that we have the human reviewing the process rather than trying to define it. I think you take away that 80-90% of effort in defining the initial one and do the review and optimization through humans is a much better way. We actually do an iterative process. We have like tool set that we have built using MCP. Now you can use Claude to actually go take like an unstructured data, create a model, see if it is good or not. If you want to change it, you can just like have a conversational way of optimizing the model and also human is in the loop so that we can actually make it better, right? So that's one aspect of the whole piece of the puzzle. But also the other side, I would say, is let's talk about electronic arts because I think we had a great session. We have external reference. And their enterprise architect was actually one of the people who was presenting at reInvent with me.
You mean
And
EA and
so,
EA?
yes, EA and EA. I just wanted to have fun with the EA. No, but actually, see the way like you will make AI systems successful is first having a clarity of thinking of what use case you're trying to apply it to, right? Their challenge was there are so many studios, right, that they have. EA is Electronic Arts, so they have a lot of games. Every game is a different studio, and there are a lot of thousands of people who want to understand what is happening, like how to make better decisions, what is the analytical questions they want to answer. And so all of this data is spread across in like thousands of tables in Snowflake and all. And so the way they started was simple. They said, okay, the problem we are solving is we'll create a definition, semantic definition of the map, so metadata graph. So they basically put what tables are there, what does what mean. They added semantic definitions to it. What does fiscal mean? What does revenue mean? All of that. They started pulling in some reference data. So if you say, pick a game and say short form version of it, FIFA 2026 versus football 26 or like FIFA, that means the latest version. So just basic information like reference information they started pulling in and they started doing really well. And it started making it easy for people to get more accurate information. Fast follow later, what they realized was, hey, that's not enough to just have the base data. There may be additional domain data if you had it in the knowledge graph that would make answers much more comprehensive. Because when you ask why questions and all, you need to have some additional information to correlate. So that started happening. They themselves talk about it in that talk is like, hey, but we realize context is way more important and tracking what questions were asked in past, which is what decision traces are, and what answers we gave and what was most useful is going to become more valuable so that in future, whatever decisions are made are powered by that. So they actually have gone through this evolution of just basically metadata, semantic definitions, some reference information to putting more context with historical decision traces and then making it happen. So I think that's a good example of like how you can build systems over time. But in addition to that, like as you're talking about, Tony, what is the adoption and what, like we have examples, external references now with people like Walmart and Uber and Novo Nordisk and Daimler, and like you can pick like Fortune 1000 companies actually coming out in enterprise. I focus more on enterprise AI and enterprise
Mm-hmm.
deployments. Our focus is that. So in that scenario, we have like large amount of customers that are actually deploying these things, and our like non-referenceable customers is a massive list too. So we see everywhere where people are going from just experimentation to real impactful use cases and all. Novo Nordisk, their Anasi graph is all of their research documents are converted into a knowledge graph. So any researcher wants to understand the second degree effects of some drugs, they can easily find it. I will give you an example. Their example is semaglutides. Semaglutides are great for diabetes patients. I'm diabetic, and so it's good for me to reduce my blood sugars. But the secondary effect of that can be on heart conditions because it basically reduces my blood sugar, which means like my risk of heart diseases go down and all. So these secondary effects of things, you can't find it just by doing some kind of a search. And having a knowledge graph that has all this context actually helps. And so it's a great example of more and more growing use cases that we have seen in enterprises. And let me close with one more. One of our biggest growth engines last year was our self-service adoption. So we get roughly 20,000 plus developers coming in and actually registering in our cloud offering. And they actually learn about graphs, they build graph solutions and all. We had almost like 80+% growth in that channel last year. And all of that is self-serve. Like people are able to come in, all these developers, analysts, bring their data, automatically build a graph, visualize it, create dashboards, build applications, and that's been growing like crazy. So, Tony, the barrier to entry has been reducing, even for any developer, anybody who wants to get started. So, I think we're solving problems across all spectrums. A lot of advanced users like EA, lot of enterprises that want to go ahead and solve real problems, and initial analysts and developers who are trying to come in and learn about the technology and how can they get started.
Fantastic. Well, we have a really great conversation. Quick conversation. I'll point out to our listeners and watchers that you have a great blog that came out recently.
Yes.
We'll post a link to that. And I haven't looked at it yet, but it sounds like you have a lot of concrete examples that people can get hands-on with, which from my perspective is probably the best way to socialize graph technologies, just actually trying it out, just like you do SQL with the SQL engine with structured data and relational data. So thank you so much for joining us. Yes.
Thank you, Tony. Thank you, Matt. I agree.
Hey, thanks, Sudhir.
The blog post is great. Also, our MCP servers are available, so you can just talk to your graphs now. You don't have to worry too much. Claude or Gemini with it is like actually really beautiful. So please go ahead and try that out.
Very nice. Very nice. And we hope to have you on again sometime as the situation evolves, because everything in AI changes so quickly.
Sounds good. Thanks, Sudhir. Good talking.
Thank you, Tony and Matt.